In this video, we're going to talk about a continuous random variable. Uh, we look at these two histograms here. These two histograms describe the relative frequency of both weight of babies. Suppose we have 100 baby and we measure the weight of each baby, and we find out there's one baby whose weight is between 4.5 and 5.5. So 1 divided by 100, we got 0.01, or you can say 1%. And we have 4 babies whose weight fall between 5.5 and 6.5. So maybe we have like one baby that weighs 6.1, another baby maybe 5.9 or 5.68, something like that. So we have 4 babies here, and then so on. So we use 4 divided by 100, we got 0.04 or 4%. So that's what we have construct the histogram for relative frequency. So 1% of baby who weigh between 4.5 and 5.5, 4% who weigh between 5.5 and 6.5, and so on. But if we want to make the class interval smaller, so instead of doing an interval between for 4.5, 5.5, 5.5, 6.5, 6.5, and 7.5, and so on, we can make each one smaller and say, because this is like a sort of like a 1 pound interval, it's kind of too big. If we make it smaller, we can do, if you look at here, it's maybe 4.75 to 5. That's one interval. And then 5 to 5.25, and 5.25 to 5.5, and 5.5 to 5.75, 5.75 to 5.6. So each interval is only 0.25, a quarter pound. And so I can find out, the percentage of baby whose weight fall between 5 and 5.25. And then percentage of the baby whose weight fall between 5.25 and 5.5, and so on. So you can see this picture, it has more bars. And we can continue doing this to make each interval smaller and smaller and smaller. Eventually, we will get a curve that looks like this. Okay, so if we compare them, you can see the curve is kind of closer to the histogram. If we just imagine we have more and more intervals, but this one has less intervals, so we only have a few. And so if we get more and more intervals, we have more and more bars, and then we eventually get a curve. Okay, so originally we have the baby weight, which falls into 7.5 to 8.5, and 8.5 to 9.5. We have 0.28 and 0.25. So if we want to find out the percentage of the baby whose weight fall between 7.5 and 9.5, we just need to add these two numbers. So it's like these two bars, the area of these two bars. And if we want to find out the same thing, the baby weight from 7.5 to 9.5, we need to add all these relative frequencies. So there should be a number on top of each one. We add all of them together. So it's kind of like the area under of all these bars, or area under these top lines of each one. And then similarly, if we want to find out the area, the percentage of the baby's weight which fall between 7.5 and 9.5, we can draw two vertical lines, and that's all the numbers between them. So it's kind of like the area under this curve. Okay, in order to find out the area of this curve, we need to use calculus integral. And so we're gonna a lot of you may not have learned calculus, so we have, in order to calculate the area, we have a table for us we can use to find out what's the area under this curve. So if you look at this shape, it's an irregular shape. It's not a rectangle because the top is a curve, and we cannot use a formula to find out the area. So we actually have to do calculus. Okay, so what is the percentage of the baby whose weight fall between 7.5 and 9.5? We find out the area of this curve, and that will give us the percentage. So this is a continuous variable, and compared to these two, we have just a few intervals, but here we have a continuous curve. So this is called a continuous random variable. It tells us the probability of the or you can say percentage, the percentage or the relative frequency of the baby birth weight. And just make sure we understand this. And the baby weight, if we look at this number 7.5, so this if we try to go above to look at this, because we said in order to find out the percentage, we found out the area under the curve. That means the percentage. And if we look at this, the area under the curve, if it's just one number, there's just one straight line, and which doesn't make sense to say the area if we just say exactly 7.5 instead of between 7.5 and 9.5. So we don't have an area, but it doesn't mean that there's no baby weighs 7.5 pounds. So what does it mean? How do we find the percentage of the baby that weigh exactly 7.5 pounds? And what we do usually is we take a small interval that includes 7.5. So maybe we can go a little bit to the left, so maybe 7.49, and a little bit to the right, 7.51, and then we can use these two, and we get a small area under the curve, and we use calculus to find out the area, and which is the probability or percentage. So that tells us the percentage of the baby that weigh at 7.5, exact 7.5 pounds. Okay, so just here, just try to have an idea what continuous function is. And probability density function is the curve we just talked about. This is the curve. And let's look at definition. Describes the distribution of a probability for a continuous random variable. It has the probability properties 1. The total area under the probability density function density curve is 1. So as we talked about before, if we add all these numbers 0.01, 0.04, and all these numbers, we should get 100%, 1. And the same for this histogram. So these are discrete. We call them discrete. So we have in each individual number. But this is continuous. So there's no gap between any two numbers. And the area under the curve means the probability. So of course, still they should add up to 1. So because we got this curve from the histogram, we just divide them into more and more intervals, and so the area under the curve should still be 1. Like adding all these bars, we get 1, and adding all these bars, we get 1. So we should also get 1 here. And the second property says the area under the probability density curve is the probability between A and B. So like we just explained, if you want to find out the probability or the percentage of the baby that weigh between 7.5 and 9.5, you need to find out the area under the curve. And the last property, the probability function is always at least 0. So we know the probability cannot be less than 0, so it's at least 0. So you would say the percentage is 0. It doesn't make sense to say percentage is less than 0. Okay, so that's the 3 properties of the probability density function for continuous random variable. So in homework 6.1, you will have to use these to help you determine if the curve given is a random, it's a continuous random variable probability density function. So what you need to do is to check three things. First of all, make sure the total area under the curve is equal to 1. So you can use the curve given in the homework. They are all very simple shapes. They don't have like curve with a curve. So you can find out the area under the curve. Make sure it's equal to 1. Secondly, the second one, I guess we don't need to check. The third one, make sure the curve is always positive or at least 0. So it will not go down below x-axis because you won't have negative percentage. Okay,